We are given this PV diagram here, and this is a cyclic process. We are going from A to B to C and then back to A, so it's kind of cyclic. And this is the area which is enclosed within that path, and this is of course reversible, because if it was not reversible, then we would not be able to trace this path at all, and that is because if this were a irreversible reaction, then these points would not be defined, because when you throw the system out of equilibrium, then the pressure and volume kind of fluctuate, and you cannot define it at a certain point. So this has to be reversible, which means you are doing it very, very slowly, infinitesimally slowly. Okay, so back to the question, and this curve is divided into three parts: A to B, B to C, and C to A. And they've given us that A to B is adiabatic process, which means that there is no heat added to the system in that process. B to C is isochoric, which means the volume is kept constant. Sorry, this should be an isobaric. It's a print mistake there. I'll fix that later, but remember that is isobaric, which means that the pressure is constant. Okay, so just write it down here. Isobaric. Okay, so B to C is pressure constant, and C to A is isothermal, which means that the pressure is kept constant. Okay, so the pressure is kept constant there, so that's why it's called isothermal. Okay, so they ask us find actually I didn't find that triangle type of delta, so this is a, I don't know, capital or small letter, but this is also a delta. So we have to find the delta S, which means the change in entropy, the change in enthalpy, the change in internal energy, work done by the system, heat added to the system. Okay, 5 things. This is going to be long, right? Not at all. I can tell the answers for the first 3 questions without even I will have to look at the question, but without even trying too hard, right? And that is because this process is cyclic. So in a cyclic process, remember that entropy, for which I'll write S, enthalpy, which is H, and I'll write U for internal energy. All of these are state functions. All of these are what are called state functions, and this implies that the values of these functions or properties of a system will only depend on the position, only depend on the initial and final position on the graph here, and which means that if I were to go from A to B, the change in enthalpy or entropy or internal energy would be the same if I went to from A to B like this, some crazy pattern like this, and I come to B finally, then the change in entropy, enthalpy, and internal energy would be the same, and that is because they are state functions. So I think that kind of rings the bell, because we are going from A to B, B to C, and back to A, which means that our initial position is A, final position is also A. So the entropy at that point will be the same, right? When you come back, it won't change, because you know that. So the initial entropy is equal to the final entropy, which implies that the change in entropy is 0. And similarly, I can say that the change in enthalpy is 0. The change in internal energy is also 0. So that kind of is very cool, because we have already within 2 minutes solved the first 3 questions of this problem. Now the third one is quite interesting, because if you want to look at it, just look at it, but if you don't want to, you can just skip it, because the intention of this video was just to keep things in mind that entropy, enthalpy, and internal energy are state functions, right? So that kind of helps in some problems like this. Now it gets a little bit of mathematics. So we have to find the work done. Okay, so I didn't mention some things here which were given in the problem, because I didn't want to confuse you, but I'll do it now. So we are given that from A to B, the graph is the graph of 1 by V to the 0.5, which means it is 1 divided by the square root of V. So that is the relation between P and V in the interval A to B. From B to C, it is a constant. Y coordinate is constant. Y coordinate is pressure here, and that is constant. That is equal to 4. You can see that. And C to A is P is equal to 1 by V. That is isothermal. Okay, so how do I go about this? Well, you must know that the work done is nothing but this area here. It is nothing but the area. So we just have to find the area, and that will involve a bit of calculus. You guessed it, it's integration, and I'll do that in the next video, just because just kind of splitting the concepts here. First one was for the intuition that the problem involving whatever, I mean that these three are state functions, so it's kind of a problem based on that. And these two are a bit they involve a bit more mathematics and calculus, etc. So I'll do that in the next video.